So we've already done central angles and how they're the same. Now we're going to do what's called an inscribed angle. And we're always going to remember, like always, that there are 360 degrees in a circle. An inscribed angle, if you look at the picture here, I'll show the picture first. This is an inscribed angle. So an inscribed angle has the vertex on the circle. The vertex of an inscribed angle is on the circle. So you see the vertex here is B, which is on the circle. That's different than the central angle, which had the vertex at the center. Inscribed, I'll say, is on the inside. And it still has an intercepted arc, right? So if I put a number in here, maybe that'll help. So like, let's say that this arc here was 60 degrees. The angle on the inside is going to be half of that, 30 degrees. So like the angle would be 30 degrees and the arc is 60 degrees. So you have this relationship where the arc is 2 times the angle, or I could say double. Maybe I'll say double instead of 2 times. The arc is double the angle, or you could say the angle is half the arc. So it's the same relationship that we saw with radius and diameter, right? The angle on the inside is half of the arc. But we also have to remember from yesterday that if it's in the center, it's the same. So sometimes we'll have those still from yesterday. So we'll practice our new rule first. If we look at number 1 here, this is an inscribed angle. ZYX is an inscribed angle, and this is the intercepted arc. The arc is going to be 2 times the angle, or 210 degrees. 105 times 2. If I want to do the rest of the circle, 360 minus 210 is 150 degrees, like that. The next one reverses it. They gave me that the arc was 100, so the angle is half the arc divided by 2 is 50 degrees. And notice we did that in red, so you could say like, hey, that's an angle versus NMP is an arc, so 360 minus 100 is 260, like that. Then it starts to get interesting because now we've got a couple things in the same picture. Here I see a central angle, which is 87, so this means the arc here is going to be 87. So 87 for the arc. But then the other rest of the circle here, this arc is 360 minus 87. 360 minus 87 is what? 273. 273. And then the last thing is asking for this inscribed angle. This inscribed angle is half. So it's 87 divided by 2, which is what? 43.5. So now you got a lot going on in one picture. A central angle the same, and then an inscribed angle that's half. Same thing happens here in number 4. Now they start me, though, with the inscribed angle. So 28 times 2 is 56 for the arc. And while I'm at it, that angle here is going to be 56 because that's the same, because that's a central angle. If I do it in a different color, you'll see that's a central angle, so that, oops, is the same, the angle. Sorry, I jumped around. And then the rest of the circle here is 360 minus 56, which is 304. So again, multiple rules happening in the same picture. Number 5 is taking it back to just that rule that the angle, if I double the angle, I get the arc. So 2 times 2x is going to be 108. Or 4x is 108. Divide by 4. So x is 27 for that one. Kind of a side rule is about an angle inscribed in a semicircle. So remember, a semicircle is half the circle, which is 180. Here's an angle inscribed in the semicircle. Well, angles inscribed divide by 2, and so if I divide 180 divided by 2, I get 90. And this is kind of, I think okay because the angles really do look like they're 90. So here it's the same picture. ADC is the semicircle, that's the arc, 180. Similarly, ABC, the rest of the semicircle, is also 180. The angle, though, which is inscribed in the semicircle, is 180 divided by 2, or 90. Here they're telling me the angle is 90, so then that means that the arc here is double that, 180. So arc DAC, which is the rest of the semicircle here, is also 180. And then this other angle, DBC, is also inscribed in the semicircle, so it's also 90. They do get a little tricky. This one's, let's see, oh yeah, this is inscribed in the semicircle. So angle X there is 90. Then the triangle adds up to 180, right? So I have a triangle there. 90 plus 55 would be 145. Just doing that in my head would leave me with 35 degrees. So we're already in some trickier problems, right? The last thing's not bad. It's inscribed versus circumscribed. A shape that is inscribed in a shape is on the inside. So you see the inscribed triangle here is inside the circle. And this quadrilateral here is inside the circle. But a circumscribed shape is on the outside. So the circles here are circumscribed on the outside. And one of the main ideas is that the vertex, each corner touches the circle on the sides. So if I want to inscribe a square, first I'll show you the wrong way. I'm not just going to do a tiny square on the inside, right? That's not fully inscribed. To inscribe it, it's got to be touching, 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 like that. Inscribing the circle, I'm not going to just do a little circle. Rather, I'm going to maximize that circle by touching it tangent at each point, like that. And now the last one, circumscribe a circle around the square. Again, it's real tight. You're touching each corner, circumscribing a circle around each square. So, second section is always harder than the first one, right? Here we are, inscribed angles.